Hello and welcome to today's Pandas tutorial. Today we are going to cover the basic and fundamental concepts, operations, or methods in Pandas. What is Pandas? Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the Python programming language. So you can go to their websites, pandas.pydata.org. You can see this. There's a documentation you can read for more information and detailed ones. And you can also install Pandas following this instruction. So I'm going to use Anaconda, Jupyter Notebooks is the most convenient way to use Pandas. And once you have followed these instructions, we can have our tutorial on Jupyter. So for this tutorial, I'm going to use actually the data provided by w3schools.com. So they have a tutorial as well, and I'm going to follow this tutorial. And what else is there to know? Okay, we've talked about this. All right. Now I've also several files here on this directory, the same directory as my Pandas, and country vaccinations, COVID data, dirty data. So some of them have been downloaded from W3 Schools, and this is also in JSON format. I will be using these. Alright, so the first thing we need to do is to import Pandas as PD. This is an alias which has been agreed upon by the community, so we can refer to Pandas from now on as PD. And in order to see the version of Pandas you're using, you can simply print PD dot double underscore version double underscore. When you run this, you should see some number here. Okay, now there are two basic data structures in Pandas. They're called series and data frames. So we are going to deal with these first because they are the most basic concepts we are going to use a lot. So series are basically arrays or like columns in a table. Just like a spreadsheet, you have columns and you have rows and you have headers. So series are just those columns, no headers. It is a one-dimensional array holding data of any type. So how can I make a series? So I can simply create a variable like L, and I use PD, which we just imported here, PD, dot series, capital S. This is the method that Pandas provides for us. And inside that, let me get rid of this first. Inside that we can have a list, a Python list. And these will be our, they will kind of make our column. So if I print L, let's run this and we'll see. So this is basically our column comprised of these John, Jack, and Mary. And you can see the indexing here, 0, 1, 2. I can give this series a name by simply typing name equals and then people. This is not going to change anything here, but here you will see the name. So if I run this, you can see that name, people, data type, object. So this is one way of making a series. Now another way of creating series is by using dictionaries, so instead of just lists. So what I can do is here, let's just say LD for dictionaries. And here I can have a dictionary like A as the key and, for example, 23 as the value, B as the key and 43 as the value, and the last one C and 44 as the value. So now, as you just see here, we have 0, 1, 2 as indices. But now if you use a dictionary, because it has key value pairs, if we make this, turn this into a series, then these will be our indices. So if I go and use LD here, so let's just use LD here. And if I run LD, you see this happens. A, 23, B, 43, C, 44. But what is so special about this? Well, the thing is, if you turn this into a series, you can do lots of operations that Pandas provides. So one of those is, for example, turning something, checking the maximum number in a list. So I have this series now called age with all these numbers here. I can use this Pandas method, max, and if I run this, I can see 78 as the highest number. So this is kind of like Python's max function, right? So you have, let's say, a equals and 33, 22, and 44. And if I do something like max a in Python, so what I will get is, okay, let's comment this out. If I run this, I get 44, which is, so in Pandas it's a bit different. It's like that. Alright, now the next important concept is data frame, which we are going to use, well, actually basically all the time. So data frames are like tables in Pandas. That is, they're like columns and rows with headers in them. So a Pandas data frame is a two-dimensional data structure, like a two-dimensional array or a table with rows and columns. So we can use dictionaries to make or create data frames. Now, I have this dictionary here, Python dictionary here. So you can see there is a key value pair, key value, and to turn this into a data frame, I simply need to use pd.dataframe, capital D and F, and then inside parentheses I use my dictionary name here. Now if I print this df, you see now we have columns and we have rows. So it's a two-dimensional array. So these are our headers, which are the keys here, and these columns, these are the values inside them. So this is what we can do. Alright, but how can I, for example, let's say this is about my workout sessions, and on the first day, index 0, I burned this much calories and I worked out for 50 minutes. So I want to know how I did on the first day. That is to locate the row. So for locating a row, like what happened on the first day or second day or third day, what we can do is, again, we have the same dictionary. We turn it into data frame, and then we use lock method to specify which row I'm interested in. So I give it the index number, let's say 1, which is this one. So if I print this out, if I run this, you can see calories on that day, 380, you see it, and I worked out for 40 minutes. But if I want to use more, I want to, for example, look at more days, like for example, day 1, index 0, and day 3, I cannot simply do this. I cannot say 0 and 2, because now we have two values. We should have only one. So I need to put these two inside square brackets. Now if I run this, you will see the first day this happened, the third day this happened. So this is to read from actually the data in a JSON or dictionary format that we have provided. Now let's say that instead of just numbers as indices, I want to have meaningful names. Like instead of 0, I want to have something like day 1 or day 2 or day 3. So for that to happen, I can name my indexes. Again, the same data, the same way for making data frame up to here, but then I'm naming my indices here. I say index equals day 1, day 2, day 3, because we have 3 rows, right? So then if I print this data frame, run this, you see here now instead of 0, 1, 2, I have day 1, day 2, and day 3. This is much more meaningful. And if I want to access them, just like I did previously with lock method, instead of giving it like 0 or 1, I can have the names, day 1, day 2. If I run this, this is for day 2, for example, this happened. Now, this might not be that useful if you want to create all the data here inside a dictionary on the spot. You might want to have it in a CSV file elsewhere, and you want to load that file into a data frame so that you can apply methods to that data frame. So the way you can do this is by simply using pd.read_csv method, and inside that give it the name or the directory, the address of where that file is. So for me, it's in the same folder of as my Jupyter notebook. So I just need to enter the name. And if I run this, let's see what happens. Look at this. So I have location, data, vaccine, and total vaccinations. And here I have the indices. But notice that I have only the first 5 rows and then the last 5 rows. And in the middle, you can see these dots, meaning there are some other rows here, but it's too long to show. So we have 10,965 rows and 4 columns. But it just shows us the first 5 rows and the last 5 rows by default. So this is how you can turn your CSV file into a data frame. And we will see why it's useful. You can do a lot of operations on these. Now, let's get to this part here. So again, I have this. So you can see that when you print a data frame, you will only get the first 5 rows and the last 5 rows. Now, if I want to get all actually data here, not just the first 5 and the last 5 like this one, I want to have also the ones in between, all of them. What I can do is to use toString method here. So I can simply say df, again I'm reading my CSV here, putting it into data frame. Then I can use this method df.to_string. Now if I run this, I get all this data here, you see, all of it. But I don't want to have it here, although this data set is not that long, so it's okay. But then if you have a long and big data set, let's say, it's a bit messy to have it all here. Okay, so that is also one way. Now, another one is JSON files, because big data sets sometimes are, or often are stored or extracted as JSON. JSON stands for JavaScript Object Notation. It's something like Python dictionary. Now to load the JSON files into a data frame, we can simply use read_JSON instead of CSV, and then use our JSON file, and then we have what you just had for the CSV. It's the same. Now viewing the data, so we just viewed and, well, we just had an overview of our files now, the first 5 and the last 5. But maybe someone wants to view the first 3 or the first 10 rows in a data set. So for that, we need to first read_CSV, because it's a CSV file. And then we can use 2 methods here, either head or tail. You can guess that head gives us the first 5 rows by default, and tail method gives us the last 5 rows by default. So if I just go for example, data frame, I just read this, put it into data frame. Now if I ask for the last 5 by giving it the tail method, if I run this, you can see I can get the last 5 rows in my CSV. And similarly, I can use also head and run this. I get the first 5 rows. I can also mention or specify another number for head or tail. I can say n equals, let's say 3. I want only the first 3, because it's head, it gives me the first 3. Tail would give me the last 3. Now if I run this, you see, I get the first 3 rows in my dataset. Another important thing is to know more about your data. So let's see what kind of information we can get. So we are reading our CSV, putting it into data frame. Then by this method .info, if I run, so you can see it's a class Pandas. It has got 169 entries. This is the index. Number of columns, 4 columns. You can see the columns here, and you can see the types here, integer and floats. And here, this is also very important. So we had 169 entries. So you can see full, 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 all of it. But here I have 164. It means there are 5 cells in my calories column which are empty, which are null. So this is a good way to realize that there is might be something wrong. Maybe you don't want any cells to be left out, or you want everything to be filled in. So this way you can realize that you have 5 places which are null. You might want to delete them maybe, or fill them in somehow. Now this is called cleaning. So let's get to the cleaning part. So here, data cleaning means fixing bad data in your data set. Bad data could be empty cells, data in wrong format. For example, you have a date, but that date is in wrong format or time. Wrong data, maybe someone filled in something wrong, like they entered a name when they should have entered, I don't know, a number, or their age, for example. Or maybe that number that they entered was kind of wrong in a way. Or there are duplicates, like you are checking the ID numbers of people, for example, or I don't know, bank accounts or something, and then there should not be duplicates. So you can also check for duplicates and remove them. So this is called clean data. Now let's take a look at one of our data files here, which is the dirty data. And let's see. So here, let me show you what we mean by these things. So here, for example, we have 450. And if you take a look, you can see all of them are either 60, below 60, but this one is 450. This is used to refer to the time that, for example, someone spent at the gym on one day to work out. This is a bit unreasonable. Maybe they made a mistake of using also a 0 here. So this needs to be cleaned. Then we have an empty cell here for the calories. So maybe this should be removed because we need all the cells to be full of information. This one as well may need to be removed because it's empty. This one as well. And here we have a date which is in a wrong format, unlike these. So we need to also clean this data. Let's start by removing the rows which contain empty cells. So for that, we can use a dropna method. So we are going to load our CSV, which is dirty data, onto a data frame. And then we can also assign a new data frame so that when we delete things, we save them in a new data frame. And then we can print out this new data frame. So we say df.dropna, and if I run this, you should not see any empty cells here. You see, for example, here, 21 and 23. See, 22 has been removed because it contained one empty cell somewhere. Or 28 also has been removed. So it will remove all the cells, all the rows that contain an empty, null value, let's say, cell. So this is what it does, and save it onto a new variable. But if we want to save this in the same data frame, not a new data frame, we can also do this by using this argument in place equals true. So by default, the dropna method returns a new data frame and will not change the original. If you want to change the original data frame, use the in place equals true. So this is how it happens. You read, you load it onto data frame, you use dropdown method, and now you give this an argument. In place is true. Now this is a changed version, which if I run, this happens again. You can see the 28th has been removed. Now sometimes it doesn't make sense just to remove every row which contains an empty cell. Maybe we want to fill those empty cells with something, like with a number or with a date, something like that. So instead of removing them, we can fill them in using fillna method. to replace empty cells with a value. And it will be applied to all the empty sets. Doesn't matter where they are. Under date, under calories. So for that, again, we load it onto a data frame. We use fillNum method here, and we give it this value. So I'm going to replace all the empty cells with 130 with this value, and this should change the original file, the original data frame. Now if I run, you should see 28, for example, which was removed previously. Now their empty cell has changed into 130. It's also happened to this date field, which was empty, and 130 is there as well. So every cell which used to be empty now has been replaced with 130. It's not that practical, is it? Because of course it isn't. You can see that this is not a date. So in order to make up for that, we can specify specific columns to only replace empty values for one column. Specify the column name for the data frame. So remember, previously we had this. We had df.fillna and a value like 130. Then in place, if I manage to spell, in place true. So we had this previously, but now we don't want all the empty spaces to be filled. We want only one subset, which is calories. So we give this data frame a specific column to change, so calories. And this way it will only fill in the empty values under calories column with 130. That makes a bit more sense, right? Now if I run, you will see that here, for example, it's none. That is not a number, so it hasn't changed this one, but it's gone down and found, for example, here 28. This was empty and now it's filled it with 130. So this was a number that I guessed that should be there, but maybe it might be more reasonable for some purposes that we fill this space, this cell here, with a mean or average number or median or mode of all these values under this column. So we can add all of these values up and then divide them by the number that you have in mean, and you can replace this with that mean. So how can we do that? So for replacing using mean, median, and mode, Pandas uses the mean method, median method, and mode methods to calculate their respective values for a specified column. What is mean? The average value, the sum of all values divided by number of values. For example, if you have 2, 4, and 6, and let's say, I don't know, 8. So the sum of these is 6 and 6, 12, and 8, 20, right? So 20 divided by how many there are? 1, 2, 3, 4. 4. So the mean is 5. Right? So this is how you evaluate, or how you get the mean value of a couple of numbers. What is the median? Median is the value in the middle. I mean, in the place that is in the middle, after you have sorted all values ascending. For example, if you have something like 1, 5, 3, you have these three numbers. First of all, you need to arrange them ascending order, so that would be 1, 3, and then 5. Which number is in the middle? It's 3. So this is a median. It doesn't matter what this number is. Let's say it's, I don't know, something like that. Again, the median is 3 because it's in the middle. And what about mode? Mode is the value that appears most frequently. So if you have something like 1, 1, 2, 3, 3, well, 3, 3. You have two modes here. You have 1 because it's been repeated twice, and you have 3 which has been repeated twice. So this one is the first that you can get by using mode method, like mode, and then you can specify the index, that is, I want the first mode that is there. So this is how you can have access to these numbers and replace those empty cells with these. And this is the way you do it. Let's do this. So you need to load this file into a data frame. Then you calculate maybe the mean of this column, the calories, that is, because they are all numbers, they're all floats. So you can add them up, well, Pandas does that for you, and divide them by the number of the items, and then you can get the mean, and then you can tell Pandas that go to the calories column and fill in all the empty spaces with X, which was the mean that you just got. If you don't want to do it with mean, you can do it with median, like that. Or you can also do it with mode, and you can get the first mode. And then you replace those with the mode or median or mean instead of 130. So this is how it can be done. Now, what about the data of wrong format? We just saw the date. Under the date, one of them had a wrong format. How can we clean that? So we can either remove it, or we can convert it to a format that we want. So converting it to a correct format. We have some wrong data formatting in our data. You saw the date. Now Pandas has a toDateTime method for this. So for that, let's go back to our file here. Where was it? Our dirty file. And you can see this one, this date format here is wrong. Look at these, it's different from the others. So what we can do is to change this format into also a correct formatting by using toDateTime method. So let's do that. Here we load this into data frame, the dirty data. Then we say under the date column, so we are referring to this, we're going to apply something to the date column. And what is it? We are going to use Pandas to convert that date column to datetime format. And then let's print it. So if I run this, let's see what happens. So this one was empty anyways, so that was null. But then 28 was the one with the wrong formatting, and now you can see it works. It has the correct time date format. And then you can see that we still have these null values anyways. So we can also deal with these just like we did before. So this is the way that you can clean also some data, that is, convert them to a right format. Another method, of course, is to remove the rows. So the result from the converting in the example above gave us a NAT or NAT value. You saw that, which can be handled as a null value, and we can remove the row by using a drop null method that we just saw. But we don't want to drop every null value like this one or that one. Maybe we just want to remove the null values only in the date format, in the date column, I mean. So for that, again, we load our data into a data frame. We specify the column. We convert everything in the date column to datetime. And once we've done that, we say, all right, now everything is in place, unless there is some empty space or empty cells. So now we would like to drop those, but we need to specify a subset now. And a subset is, of course, date, the column. It's not every cell. And in place is true. So if I run this, you see there is no NAT here. There is no NAT. Oops. There is no NAT here, which was previously on what column was it? Yeah, on the 22nd row. Now if you go down, you don't see any 22nd row. But we still have these null values under the calories column, right? So we didn't want to touch these. All right. Now, fixing wrong data. So what is a wrong data? Let's take a look at here. There is this part I talked about, like 450, which looks really wrong to me. So let's just deal with this manually. So if you have a smaller data set, it's easier to go through it and see, oh, this doesn't look right, because everything else is below 60, and all of a sudden we have 450. And it's a bit kind of difficult to work out for 450 minutes. So maybe the user intended to enter 45. So based on what we know already, we can tell, okay, maybe we can check this and correct it. For now, we can't see it. So how we can replace this is by, first of all, going to that column which was 7 under duration, right? So it was here, it was 7, right? Index 7 under this duration column. So 7 under duration, and we set it equal to 45 instead of 450. So this is basically like the Python lists. For example, if you have a list of, I don't know, 1, 2, 3, 4, you can replace, let's say, number 2, for example, which is index 1, right? You can say L index 1 from now on is like 20. Now if I print L, okay, let's comment these out. Now if I print L, I should get 1, 10, 3, 4. You see, 1, 10, 3, 4. So this is basically something like that. And let's get back. So we are specifying the index, but we should specify also the column, because not everything in that index. So the column, index 7 under duration column, we want it to be 45 instead of 450. But it's not practical for large data sets, right? So to replace wrong data for large data sets, you can create some rules. For example, set some boundaries for legal values and replace any values that are outside of the boundaries. For example, loop through all values in duration column. If the value is higher than 120, set it to 120. So you can do that. You can go through, loop through all the values under duration. And whenever you see a number which is, well, whenever Pandas or Python sees a number which is above 120, they will change it to 120, something that makes more sense. So let's do this here. So first of all, we're loading this again into a data frame, and then for x or for I, whatever, in df.index. So we're going through the indices. If the x in this column, the x would be 0, 1, 2, 3, 4, so it would continue, right? So if the location x under duration, if that value is above 120, then set that value, that x index under duration, set it to 120, something like this is the same. So it will go through our indices. It would say, okay, index 0 is, for example, 50. All right, okay. Next one, index 22, for example, under duration is 200. Oh, okay, then what shall I do with it? That index 22 under duration, set it to 120 instead of 200. And then if we do this, you should see that instead of 450, Now we have this. So it will go through all of these indices one by one and checks this value. If it finds one of these values to be above 120, it will set it to 120. So that's also one way of dealing with this. And of course, another way of dealing with it is just removing it. How? Again, with the same for loop, you can go through this by for loop, and if that number is above 120, you can drop it. So we're not using drop now, we just use drop because it's not necessarily empty. So then you should drop that index, that row. So this is one way of doing it. Now let's just run this as well, and then let's go to index 7 to see what has happened. You see there is no index 7. It's dropped that row because it contains some wrong number. So you can also use this for dates as well. Like if it is like 220, I don't know, 25, for example, do something. Or other numbers as well. Now, discovering duplicates. So to discover duplicates, we can use a duplicated method. The duplicated method returns a Boolean value for each row. So what it does is goes through all these values and checks if there are duplicates, and then it gives us false or true. This is good if you want to check the ID, for example, or bank accounts, which should not be identical. So let's do this. So let's load our CSV file again into a data frame, and then use this method, df.duplicated. If we run this, look at this. You see, we have all false except this one, index 12, which is true. So it means we have this value, the value of index true, we have it as a duplicate. So it needs to be removed. So what we can do to remove the duplicate is also very simple. We could simply say and load it here, and then df dot this method drop underscore duplicates in place true. That is, apply the changes to the same. Now if we run this, there is no index 12 because it contains some duplicates. Now it has been removed. Good. Now data correlations. Okay, this is also very interesting, to find relationships between several variables. So we are going to use this method, core, which calculates the relationship between each column in your data set. But what is a good correlation? So a correlation is basically something like if you, I don't know, run more, you burn more calorie, right? So if you do more exercise, you do more workout, you might burn more calories. So there's a positive correlation here. That is, the more you run, the more calories you burn. So that's a positive correlation. And that correlation can be in terms of, let's say, percentages. For example, there is a 90%, let's say, correlation between these two, for instance. It's normally a number here between -1 and +1. 0 means there is absolutely no correlation whatsoever between these two. They have nothing to do with each other. They don't affect each other. -1 means they absolutely have effects on each other. There is a 100% relationship between these two, but in a negative way. That is, for example, the more you do something, the less you get something. So the more you run, I don't know, the less the chances of your heart attack can be, for example. So, or the more you do workout, the fewer the chances of, I don't know, whatever disease can be. So that would be a negative correlation. It means there is correlation, but it's negative. So what is a good percentage for that? What is a good number? So it's good to, it's safe to say that you have to have at least 0.6 or -0.6 to call it a good correlation. Now let's see what it means in action. So we have our data, and let's get the correlation between the columns in our data. by this method. If I run, you can see this table here. So we have duration. Now the correlation between duration and duration is of course 1, because when you work out for 2 hours, you have worked out for 2 hours. That's it. But the correlation between duration and pulse. So if you work out more, as you spend more hours in the gym, does it really affect your pulse? It has some negative correlation, but still this is not significant, so we can't really say there's a correlation here. Also with max pulse, nothing special, but with calories, look at the 0.9. That's a very high correlation. It means the duration of your workout has a positive and strong relationship with or correlation with the calories you burn. So here we have a strong correlation between these two. But then for the rest, we don't have much except maybe max pulse and pulse, which is 78. That's also good, but it's understandable, pulse and max pulse. So this is also the way you can get the correlation between two columns or more. Now another interesting part is about plotting and making diagrams. So we can use plot method to create diagrams, and we can use PyPlot, a submodule of the matplotlib library, which is basically a great, well actually library for doing diagrams and plots, to visualize a diagram on the screen. So for that to happen, we need to import matplotlib.pyplot submodule as, just give it an alias plt. We put our CSV file into this data frame. Then we say, okay, we want to have the plot of it. So if I remove this and if I run, nothing happens here, but it does. So this is what we can do. Yeah, and the reason is that we actually needed this as well, but yeah, but Jupyter, Anaconda kind of managed to do it anyways, even without this. So here we have this this diagram, and you can see that there is this with these lines and colors. So we have duration in blue, then we have pulse in orange. So you can also see that the higher the duration, the higher the calories, right? So, and you can also see, yeah, it's really interesting to have this diagram. Now another diagram that we can have is also a scatter plot. So we simply need to mention the kind of our diagram, which is in this case scatter, but we need an x-axis and a y-axis. So we are going to use duration and calories because we know that these two have a high correlation. So we will use duration for the x-axis and calories for the y-axis. Now let's see. So again, we are importing this, and then we are going to read it into a data frame and then plot. But then inside the plot, we are going to specify the kind of the plot, which is scatter, and x-axis would be our duration column, and the y-axis is going to be the calories column. Now if we run this, you see this scatter diagram here, and you can see that this increases, right? So the higher the calorie, the higher the time, the higher the calories that you burn. So you can see the correlation here. And then we can have the same with another one with the calories and max pulse, which they do not necessarily have a positive correlation. So if I run this, you would see, yeah, there is no meaningful, let's say, correlation here. Now the last thing that we are going to cover is a histogram. To specify that we want histogram, we need to give it the kind argument hist, and it needs only one column. So it shows us the frequency of each interval, that is how many workouts lasted between 50 and 60 minutes, for example. So let's just take a look and see what happens, and I will explain. So here again we're importing this, we are loading this into data frame, we specify the column that we want to plot, and the kind of that plot is going to be histogram, hist. So if I run this, you see this here, that you can see frequency, that there are more than 100 workouts, right? And then most of these workouts lasted between 50, or let's say 40, and something like 70 almost, or 65. So this is what his histogram does. It just gives you this frequency of each interval. Okay, that's basically yeah, the fundamentals of Pandas. You can always go to the documentation on this and learn a lot. Thank you very much for listening and watching.